Welcome to Developer Meeting on Sunday the 2nd of April. A lot of people here today. Thanks for being here. So I think we have one topic that we already discussed before, and I want to recall it here to be on record. I think we have to, in order to approach the first alpha version more speedily, we thought that it would be a good idea to go with the image that Fabio created and Wayne already tested locally, and we put it on the drive and we make then an official GitHub link or Discord link for us, so that you all can work not from scratch, from zero, but from an image that is already working. The only question I've not cleared out yet is whether this is with the cleared credentials. Wayne, do you know how to? Is there a password coming along with this image, or is it leading you through the first onboarding session? Anyhow, look it up please and tell me later on. We'll find this out. But the idea is that we have then an image that everyone can build upon and put their codes and binaries on it and test it there. Okay, we cleared it out later. So first of all, I think we have some new demos seen today. I hope. That's why I'm calling out for, let's start with David. David, you there?
Yeah.
Okay.
Can you hear me okay?
Yes. Something you want to demo us today?
Yeah, it's not too impressive. It's just I was playing around with cloud motion detection. Just there was a suggestion last week from John. It was quite interesting, and also Dan, discussion with Dan as well about maybe using the cross correlation over a region of the frame to work out if we can detect cloud motion direction, get a vector. So I managed to, with a little bit of help from ChatGPT, put something together that works. I haven't had much free time this week, but it seems to do a reasonable job. But it led me down a bit of a path, looking into literature as well, and there's quite a lot written on this and some really interesting work done on it. So I'll demo the work I've done, but there's probably better ways of doing this and more efficient ways of doing it. So I'll just share my screen. Just bear with me a sec. You guys seeing that okay?
Yes.
You seeing that okay?
Yep.
Yes, we see.
Great.
Yep.
So yeah, this is the cross correlation. Yeah, it just draws a vector, does a cross correlation between two frames. It continues to do that, and then it produces a vector. And it does a reasonable job of pointing in the direction of the cloud motion. See if there's a bit of a better demo here. Here we go.
What do you do exactly? Like create segmentation maps, clouds, and then calculate based on that? How do you track clouds?
It's just taking this region over two frames spaced apart in time, and then doing a cross correlation between the two, and then looking for the max between, and then we can derive a vector from that, and it does quite a good job. I mean, the length of the vector is the speed of the cloud, but the direction seems to work. The other thing this is fairly, it runs really efficiently and doesn't. But there's another approach. So I was able to kind of, I can just, kind of expand that out so you can do like a grid and do and get vectors over these different blocks if you like. So I was playing around with that, and then there's also like a optical flow. This is a bit more computationally demanding, but it still seems to run okay. You can see the issue you have maybe with a fish running this on a fisheye lens, you get because of the distortion. I'm guessing you get the cloud seeming to go quicker around the edges. So there's maybe something we can do with flattening out the frame. I don't know. I've not really done anything like that before, but welcome to any suggestions anybody might have. But yeah, the vector.
Could you envision? This is awesome. Could you envision doing like from the, I guess, the computational demand that you're seeing? Could you imagine a bounding box on a cloud and then doing a denser vector field, on the actual cloud itself? I guess how computationally intensive was increasing the density of the vector field? Was it substantial, or was it trivial?
Yeah. I mean, this is 800 by 800 pixels, and I'm doing this optical flow, I think a frame every second, so it looks back at the previous frame and calculates which was a second 25 frames ago, and then calculates the optical flow again. But yeah, as soon as you start to do it every frame and bigger resolution, higher resolutions, it starts to become a real resource hog. But I don't really know how often you would need to do it. I mean, I was talking to Mike, and he mentioned that something like this might be useful to put in like an observation node for ROS. I guess the more we know about the environment, the better it is, and for us in tuning the tracker. And
down the road, you probably wouldn't need to do this anytime soon, but down the road you could use a vector field to do a topological map of the cloud to use as a reference for an object. So if you have an object going through a cloud, or underneath a cloud or above a cloud, then you have a topological map. You can use that vector field to create that, especially if it's moving. You can enrich that with weather, open weather map data and whatnot. But just a thought to keep for the future.
Yeah, no, that sounds really interesting. Yeah, thanks, Dan. Yeah, I'll give it some more thought. I was intending to spend a bit more time on it this week, so I'll try and report back.
And you only need to do that, very periodically, and then you can kind of have that topological map, for that bounding box of the cloud. Again, it's going to change, but you wouldn't have to do it constantly.
I'm keen to understand stuff that Nicola's been doing with the neural net and some others as well, and how this sort of thing could help, or how the cloud coverage estimation could help. I'm still to get my head around neural nets and things like that, but I can understand how this sort of thing would be useful for tuning background subtraction, motion detection. But
yeah, so one thing I can see is that you can use compare the velocity of this with the velocity of other objects to have suppress some false positives.
Balloons, basically.
cool.
Yeah, or just some darker spots in the cloud that are falsely detected as an object and such.
interesting. Yeah.
I've seen such things in tracks while I was labeling material for image classification. There is a darker patch of the cloud, and tracker picks it up and tracks it across the frame.
I guess further down the line as well, when you've got the pan, tilt, zoom, that would be really handy to understand where these patches are. If you've got objects that are occluded by cloud and things. So.
Yeah, and you can apply. You could zoom in on an area and apply more, topological resolution by zooming in and getting a better, image. Especially because it is moving and you're getting a, you're effectively kind of doing photogrammetry. But yeah.
Hey, David, one question. You compared your, let's say, straightforward algorithms with the optical flow, and you said that the optical flow was much more processor consuming, right?
Yeah, that's right. Yeah, the cross correlation was definitely less demanding.
Okay.
But I need to do some proper timings of them both. They were both slightly different frame sizes and stuff like that. So it wasn't really it's just a feeling I got for it.
So could you compare, for example, take the same raster with your algorithm, let's say 10 by 10, for example, and then, because I saw that you also could segmentize the whole view into optical flow areas or segments, because there's only one representing a whole segment, that you also take 10 by 10 segments from optical flow and compare that? Could you do something like this?
Yeah, sure. I'll work on that this week. Yeah, and see if I can report something back. Yeah, sounds good.
So at the end, Jannik, can you hear me? Jannik?
Yes, yes, I hear you.
So, for example, if we can map out the sky with vectors of chasing shadows, and we would know with some accuracy what the current cloud layers are. I know, very rough, but let's say we know about the cloud layers. We could then derive local velocity in the clouds.
Oh, you mean yeah? If we had the height of the cloud layer, right?
Yeah.
Yeah, and I think that should be possible.
I mean, it's always with the boundary to its accuracy, because if the cloud layers are always plus minus something, right?
And getting
I mean, then you could.
Sorry.
When you think about when we actually monitor an object and it is below the cloud layer, then we probably can at least have some boundaries on the speeds of the object, I guess, with some guess values. So we know the object must be below 1,000 meter height or something like that.
Yeah, genau.
Sorry.
I have a question. Maybe that's not so sensible. Just an idea I just had. We have two cameras, right?
Multiple, yes.
Yeah. I wonder if their distance. I don't know how big the whole thing is and so on, and I haven't done the calculation obviously. But could you, for the cloud distance, could you look into a guesstimate from the parallax between the two images?
So yes, there's the station as it is designed is with two cameras. One is a fisheye and one is a pan tilt camera, a zoom scope. But because you know the distance of both, you know the focal length of both, and when you take the angles in both, let's say the inclination and the azimuth on the PTF, as well as where is the point in the fisheye view, because the fisheye is 180 and so forth. then you can correlate and recalculate the distance and size with a certain degree of accuracy. Because the closer you come with the two eyes, the less the accuracy will become, of course. But still, with our two eyes, we can do a good job. And the bigger the distance, the higher the accuracy, the lower the accuracy will become.
Plus, we also have you can supplement with cloud radar data, and I don't know how accurate that is. Depending on the different API sources, but if it is high enough resolution at a local level, you may be able to approximate cloud size and velocity there, and reinforce some of that height or again size. You can also potentially get some size information with respect to an object with respect to that cloud. Not just the object height, but the object size potentially.
I think we can certainly get an estimation of about distance and size and speed when we know some boundaries like cloud layers. So I want to pick up on John's idea. I think it's a great one, because consider an object standing in the sky. It has a contrast towards the background, which is a cloud, which chases in some direction, but this object would still stand still. A normal tracker would not react on that, because for the tracker itself, the coordinate is stable, and so it's a non-moving part. But because the cloud layers chase around, it's something that we shall be alerted on as well. I think that's a great idea.
The relative movement.
Relative movement, and actually the non-movement.
Relative to the cloud.
Yeah. All right. Any further ideas towards this? Okay. I'm very happy that Paul is here today. Paul, UAP Paul, are you there? Yeah. Good to see you.
Hey, how's it going? Good to see you.
I think you can demo us something today, don't you?
Sure. So just to give a little introduction, I'm taking a slightly different approach and targeting more higher end hardware. I think it's going to take a while to get this right. So I think what you guys are doing is great, and you're probably going to get there way before I do. But I think this will be a different approach to solving the same problem, but be capable of interacting with the system. So it's based on the simple tracker and a neural net working together. So let me see if I can. Sorry, I'm a Zoom person as well, so let me see if I can figure this out. Share screen. Okay, can you see that?
Coming? Yes.
Can you hear me? Can you hear me?
Yes.
All right. Good. Okay. So these are some of the latest captures that I've had, and these are just sort of random examples. This one, so I haven't got my camera in focus, so you can really see just a tiny blob, and that's what the neural net's been trained on. The way that it's working is it has the last 3 frames grayscaled and then composed together, and which creates a full 3700 by 3700 image with, in this case, you see the RGB layers there of this blob. Because the blob's white, you'll see RGB. If the blob was black, you'd see CMY. this guy here, so this represents what the neural net's seeing, although it's seeing the whole thing. This represents the track, so this is track number 3. The white square is the detection by the neural net, and the circle represents the lock on that object. And then this is just the zoom on the object. So I'll show a couple of examples. So this is the first time it has seen a low-flying plane. So it actually decided this was a bird. But what I can do now is correct the label on this and feed it back into the next training layer. So here's the annotations. So I've modified that track label to say plane, so that when I train it next time, it'll correct it. Some examples are some bad examples. I'm not sure if you can see here, because so there's actually a flock of birds here, and you see where it goes red. That represents that it's lost the lock. Now, I don't know if you guys can see this, but the bird is actually here that it was tracking, so it didn't manage to pick that up. But if you look on this guy, the size of that dot is very, very small, and it's difficult. So even I have trouble on the large image picking it up. I'm also tracking the frames per second that we're recording at 7.6, and any drop frames. So the way that this was processed is I captured it first at 7.6, and then I processed it using the neural net. If I capture and process at the same time, I can hit about 3 frames a second, but I haven't done any optimization yet. So I'm fairly confident I can, improve that. Mm-hmm. But it's running on fairly high-end hardware, so it's running on a 3090, which is probably 10 times faster than a Onyx. So that gives you some idea of the sort of comparable hardware that it's trying to use, which is itself is probably 10 times faster than the Nano.
Mm-hmm. So you said initially, do you still demo something, or do you close your stream? Paul?
Did you guys not see any of that?
No, we did see. I did.
No, we saw the video, but now we see the mosaic of Discord. So your stream is still open. You still share your screen.
I see. Okay. Well, I don't really have much else to share.
Don't click this one. Don't go this. Just stop your sharing. The very in the middle, the center. No, on the right. Not to the right. Far right. Yeah, now you see the pop-up menu, and there the center one of the white one. The center. Yeah, that one. Thank you.
Sorry. Thanks.
Yeah, the Zoom people, I know.
Yeah.
So you first initially said that you're not feeding the complete image, the complete frame to your neural network, but only a cropped version, right?
No, I am. The full frame is going to the
full frame. Okay.
So 3700 is going to the neural net.
Okay. Wow. Wow, it's pretty amazing actually that you still get 3.6 frames per second doing both.
Yeah, it's currently bound on the CPU, but I mean, even like you saw the bit where it said FPS in the top left-hand corner, that's like stamping the frame. Even that's dropping the frame rate by like 3 or 4 frames a second. Mm-hmm. So I just need to do some optimization there.
Mm-hmm. And you use Simple Tracker for why then?
Well, Simple Tracker is more of a framework, and one of the plugins to the framework is background subtraction. So there's a couple of sort of backends, if you like.
Okay.
And so I replaced that backend with an inference plugin that then talks to the RCNN repo that you guys have.
So you're basically not using the tracker as from Simple Tracker, but let's say the background subtractor.
So Simple Tracker, the way I designed it was it has various plugins. So you have a set of plugins for the input. So you can have input from a video, you can have input from a camera, and then I've created a new input for ZWO cameras, and then there's a detection layer, and one of the detection layers is the background subtraction. I've created a new detection layer for neural nets. Then there is the tracking mechanism, and previously we were using CSRT as the tracking mechanism. That's just way too slow for what I was trying to do. So I developed another tracking mechanism based on a Kalman filter and Hungarian for cost matching track tracks that are closer together. And then that whole thing. So it's basically just an extension of the Simple Tracker.
So from my point of understanding is that first of all you need a background subtractor in order to see where is something moving. No, did I understand?
So not for what I'm doing. So you can configure it in you can configure it in different ways, right?
Okay.
But the way that I'm configuring, it's using the ZWO camera input, the neural net inference, and the custom Kalman tracker.
Okay. So not using background subtractor at all?
No background subtractor. This is all neural net.
Okay.
And this neural net is performing classification, what the object is.
Correct.
And it looks the entire frame.
Correct.
And what when there is multiple tracks? How do you resolve that?
So that's what the Hungarian cost calculation does. So if there's two tracks and they're moving like this, so the Kalman filter will approximate position. So if they're moving like this, it'll say, okay, I think this one's going to be here, and I think this one's going to be here. And then the Hungarian cost calculator comes in and compares where it expected it to be with what the detector detected. Say the detector said, oh, okay, I saw something here and I saw something here. And then the Hungarian cost calculation just says, okay, the distance between these two are smallest and my overall cost. So I want to minimize these distances. And my overall cost is to match that object to this object and that one to that one. So that's your track.
Oh.
Okay, cool. Huh. Nice. So, okay, go ahead.
Yeah, so I've got a bunch of more work to do to keep feeding it things where it's getting it wrong, but I'm able to just sort of let it run and then process it, and then I'll just go through and correct all the labels that need correcting, feed it back in. And then it struggles with brain. So I'm thinking of having an additional detection head that'll say what the weather is, and then nighttime as well. So it does work at nighttime, but my overall MAP is fairly low, and I think that's because it's really struggling to comprehend that a plane looks like a blob during the day, but it looks like a flashing light at night. But they are actually the same object. Mm-hmm. So I'm thinking that if I have an additional detection head that says, like time of day, is it daytime, dusk, dawn, nighttime? And then I have an additional detector head. So I've currently got two detection heads. One detects, one classifies. And so you add another one for weather and you add another one for time of day. And then that'll get it recognizing that, oh, this is a nighttime and it's raining, therefore I shouldn't do anything. Or some other combination. So you could,
I have a suggestion there. Essentially, isn't the brightness can just be calculated from the pixels directly, and then you would just use this value of overall brightness of the image, because then all the night daytime changes over the year, different parts of the world, you get lots of those aspects. When is it dark and when is it light, and how strong is it dark and light, and then you actually get this value that is continuous and it just comes straight from the image's average brightness differential.
so that would be something you'd have to feed into the network,
Right.
and then that would be an additional input. That would be like a multimodal system. So at the moment, the system is using image input only. So I'd have to have something that combined that type of input. I did try something like that, but struggled a bit. So yeah, that is a valid approach.
But a simple solution could be David's approach, cloud estimation and the daytime estimation. Or
there's
cloud.
another way that you could do it. Has anybody heard of Flux? F.LUX? It's one of these like screen dimmers. It turns out it takes out the blue light and only leaves you with the red, so that your circadian rhythm is okay and all that. Whatever. So it just changes the way your screen looks, so you can actually get to sleep on time, and it queries time servers to know when sunset and sunrise is, depending on your location.
Yeah.
So I mean, it's the same mechanism that we could use, right?
Yeah, but it's not only the time, it's also that when you have a dark cloud layer that could be pitch black.
Artificial lighting also.
Fair enough. Good point.
Yeah, I guess that would be that was actually gets to my question. Are you primarily wanting to just understand how bright it is outside, or is it, do you first want to know, is the sun down? Primarily because you could probably first you can deterministically know if the sun is down or not just with a calculation. And then if not, then maybe do a brightness calculation based off of pixels, because that might give you a little bit more information.
So what I'm trying to do is get it to understand the concept of day and night, or raining, or cloudy. And the way you do that is you give it feedback, the neural net feedback on the loss, and so it understands this is what I'm targeting, and so it gets to understand what those things is, and then it will understand combinations of those things.
So in that case, I would do the calculation and just give it state with respect to, or even an API that gives you more of a detailed description of it is like the sun is going down, like the more detailed, solar data, really.
Yeah, as I say, that is a valid approach. It would necessitate a multimodal input for the neural net, which I don't have at the moment.
There's Open Weather Maps has solar radiation API that's, I think, free. I don't know if that's if you're doing that or not.
Yeah, getting the input data isn't difficult. It's incorporating the input data into the neural net.
Got it.
All right.
Cool.
Well, great job.
All right.
It's
Thanks,
very
everyone.
impressive.
Yeah, absolutely. I think it's a path that is absolutely important to go, because what we do here right now is going an alternative path, because we actually wanted to do what Paul is doing, but there is no hardware that is from the shelf and easy to get and on low cost and getting it everywhere. So we are bound to smaller devices, and therefore we need to do more steps in our detection and tracking. But at the end, maybe in 5 years, the hardware that Paul is working on today is on the same level as the hardware we're working today. So in a couple of years, maybe we then shift over to Paul's approach. But for the time being, we have to do what we do. And that's why I think it's very important that we do both routes, both paths. All right. Any more questions or ideas along this way? Then I would say, if there is no other one in going into demoing today, right? Rebecca, did you want to share your video? Rebecca?
I can
Or,
I can show. I have a little bit of work.
yeah.
It's really small and
Okay.
it will be over real fast. So screens. Do you guys see anything?
Yes.
So it's a small notebook to see how our data set is balanced. Here are all the classes and amount of examples. And here is the image size, which is basically area in pixels. So we see some kind of distribution. And here we have the dimensions of the image displayed. So most of them are square, but there are some that are not 1 by 1 in aspect ratio. And this is what was used for CNN classifier for small crops. Yeah, this is the code here. But I can't run this project right now. I broke something with Docker on my PC, so if you guys want to try, you can do it local. I gave some basic instructions. There is README. It's still not finished, but you can guys, I think, check it out. And next thing that I plan to do is to finalize this script, which will generate a new data set for training the sequential model on the crop data set.
Creating a new data set based on the...
Based on the existing one.
Okay. Can you explain what is going on with it? Okay.
So here we have this data folder, and here are all the classes. And you can see this is all from the same track.
Mm-hmm.
And it's all flat like this. All plain tracks are in one directory, and this script will create folder for each track inside of plain. It already exists, but I changed the layout of the project a little bit, and I need to adjust the paths, but 99% is already there.
All right.
And then I generate that, and next thing is to implement this transformer-based classification algorithm that looks at time series data, and it uses tublet encoding. I'll send the code that I plan to use. I think this is it, but I will send you guys when I finalized.
Okay. Can you upload this paper to the site, or now give it to me so I can put it on the science
Yeah,
channel?
when I confirm that that's the one that
Yeah.
goes with the code.
Okay, cool. By the way, if someone of you has a good paper that we shall keep, please send it over to me. I put it on our science channel so that anyone can have access to it. Hey Nicola, one question. At the beginning you had this correlation and you found that not all images are 64 in square.
Yes.
I think we already have talked this out. It is something that has to be changed in Mike's code in the simple tracker, so that really 64 only square images shall be written
and
out.
to reconsider our strategy how to handle tracks that are approaching the border of our field of view.
Yeah.
Because right now the problem that I noticed is that a tracker tracks something across the sky, gets to the edge, and then gets stuck to it. And this is also the place where the 1:1 aspect ratio breaks, and where tracks just go random, like it's jumping on the edge, few arc seconds up and down.
Yeah, the thing is, if Christian would be here, he would have said that he doesn't care about the edge. Because anything that is below the 30 degrees is not calculable. Okay.
Oh,
But,
really?
yeah, because first of all,
original.
it's not a perfect sphere. It's all a fish eye is always a squeezed sphere, as if you take a ball and stand on it, so you squeeze it. So the projection is wrong. It's not spherical. And then you have the atmosphere, and that gives a lot of refraction. So objects are actually in reality somewhere else as you see them when you look to the horizon. So there's he doesn't
better not risk it. Error stuck up and then.
But I think it's good that we can track things close to the edge, but not necessarily directly at the last pixels.
And it would simplify our code and produce much better data if we just say, okay, if it's going above, I don't know, 150 degrees, just don't track it anymore. And then we guarantee ourselves that our crops will still be 64 by 64 and they will not lose the aspect ratio.
And is that being calculated, or is that are those crops being actually taken within this simple tracker, which would be the GitHub simple tracker repository?
Yeah, I can show you the images if you would like.
Okay. Just as I'm kind of getting up to speed on where everything is.
So this folder is actually better. See? Do you guys see it? I'm sharing the screen.
Yeah.
So these are the edge cases. There is a lot of these examples in the track material, process track material, so much that I had to train a special class just to detect that. And my idea was, okay, let's use this information when we notice that track gets classifications that belong to this edge class. We terminated tracking because I noticed that tracking keeps
sticking there.
Yeah.
Just to be clear, the image itself, is it size? It's not a square image, or is it that it is a square image and it's just has black pixels?
Yeah, both. When they are on
Both.
the middle of the frame or far away from the edge of the frame, they are square always. But as soon as we approach the edges, and then there is no more space for us to create 64 by 64 crop, then it gets, I don't know, 35 by 64.
So
where is this black shadow coming from?
That's the edge
optic,
of the
edge of the optic.
View.
yeah.
So this 64 by 64 topic, just to lay to the graveyard, please. It is a mistake in Mike's simple tracker, because he uses the center point of the target and adds 32 pixels to all sides. So when he reaches the side and edge where the image ends, he reduces because it's a black void and the tracker doesn't. There's no the background. There's nothing to crop to. So he just, if there's no 32 pixels to add on to the right, for example, he ends there, and so you have, let's say, a rectangle that's 64 in height, but only 32 in width, for example. So what he shall just do is create always a 64 and put it as close as possible to the tracked object, as centered as possible. And this as centered as possible shall be just in this algorithm that creates these frames. I mean, it's just 2 lines in his codes.
Yeah, I think it's really simple. Just add the check if cropped part is 64 by 64 and proceed. If not, then return.
Either skip it or move. You can also move the 64 square, let's say, close to the object. If the object is really on the edge of the image, if it's really on the edge, and you no more image to the other side, then just put the rectangle there and let the object within the view move to the side. Yeah, it doesn't have to be in the center, right?
Yeah. Or from data purity perspective, we should just ignore these cases. Let the data always be centered when it can, and we will lose less than % of data. It's not really important.
Yes.
And the quality of data will increase because I don't know if you guys saw the ratio of classes. We have a lot of edges. Like 30% of all examples are just tracker being stuck at the edge.
So to explain everyone what's going on, if the tracker follows an object, let's say a bird over the screen, over the view, this bird can then reach the edge of the optic because either it flies too low or it's too far away. The tracker follows the object until it's not trackable anymore. But the tracker has also a feature in itself which keeps it alive for a certain number of frames, because it can happen that an object is just shortly invisible, but there again, let's say 2 frames after. So there's a kind of an elasticity in the tracker to be able to follow objects even when they are shortly behind a cloud, for example, or whatever. And this is on the one hand we need that, but on the other hand it keeps the tracker from hanging on the edges for a couple of frames.
Yeah.
But this is actually not no issue. I mean, if you don't get first of all, if you don't get 64 square images, ignore them. But then if you just get the same image, we can do it on
2 sides. We can do it in simple tracker, or you can do it in my dataset preparation scripts. So that's not a problem, but I would say it is better to do it in both places.
Yeah.
Just in case.
Yeah, absolutely.
Because we have legacy data on my side, and for all the future data from simple tracker.
Yeah. I mean, we can also incorporate trustability to object identification. For example, if the coordinate is within a certain degree of inclination, then there is higher classification possibility, because there's more. The atmosphere is less because it's thinner
less
vertically
distance
up.
to
So
the object.
yeah. So maybe inclination can also
Yeah,
be a variable.
actually, true.
Yeah, I think that's extremely important. It's a very different amount of vertical space. Yeah, it's not. Yeah, just a very different length.
Yeah.
Now that we talked about these multimodal AIs, like UAP Paul showed to us. I mean, it's not yet multimodal, but I assume at some point it will be.
Mm-hmm.
Yeah, this kind of data is useful. We should think about it. Same with clouds, optical flow of clouds, and yeah, maybe at some point we're going to need the data to train some Giga AI.
And you have the same issues like Paul has with daytime. So a plane in the night.
I don't have planes at night.
Okay.
Not a single example.
So yes, I have to explain this. Why this training data set is created with the old SkyHub software. When it was running on my station for almost 3 years, I created this data set. It's 2.5 terabytes of videos. It's material we use as training data for lack of anything else. But yes, now the QHY and the fisheye. And I hope that we get the image of Fabio up and running on all Pis. Then we will create live data. So we are at that edge of transitioning from old training material to fresh one.
If individuals want to upload video for training, where could that be done?
Nowhere yet. I'm still setting up the system for storing all the files, training materials, and I plan to create concept of ML training runs where I keep all the informations like what config was used in simple tracker to produce the crops, then all the files that belong to that one processing batch of simple tracker, then all the batches composed in ML training dataset. So this all needs to be tracked and distributed on the internet, I think. So I'm still working on this, and right now I have plenty of data to work this hard drive that is still in mail, but I will have it in like 2 weeks maximum. There will be a lot of data to play around. So the major problem is actually after we process the video data by simple tracker, we need to classify the crops by hand and do it really precisely. I did classify 70K of images, but that's not enough. It is enough if it was real high quality data, but in our case, it's only daytime and it's only planes up close, really low in the sky. I don't have fighter jets, I don't have drones, I don't have aircrafts at night, balloons. There is a lot of data to be collected, and classified first by hand and trained.
Yeah. So we did this classification by hand once based on this old training data.
Yes.
We had, I think, 5 or 6 people helping out for a couple of days, and we created.
This is low quality data set, and we have only 10,000 of sorted images.
Would it? I've never worked with the FlightAware API personally, but would it make sense to toss a camera up and couple that with FlightAware API data and just specifically look for planes at night and get kind of deterministic information about.
We can take ADS-B data and figure out based on that where is this in our
You can know the
whole
exact
sky
plane
frame.
type.
Yeah. But at first, I'm interested, is it plane or a bird or an insect?
Sure.
But later
But
on,
I guess
when
my point is that you can have that your training data can be extremely good and precise.
and it could be produced using this external API. I think in theory it
Yep.
could. I mean, the main thing that I see that would block me from doing that is to figure out, okay, I have one plane that I discovered using ADS-B source, and he's in my vicinity, but where is this in my fisheye frame? Where are the coordinates? If I could tie these two things, then yeah, then
Well,
it's
as long as if what I would probably do is I would just look for isolate the timestamps of the planes that did cross that your coordinates.
And sorry.
And just look, you know, I mean, you should be able to see the actual flight path.
This is actually solvable because I know the station,
Yeah.
where it was standing, I know the direction, I know how to identify north in this view. So it's basically everything's known.
Yeah, in theory, if we can say, okay, this flight from ADS-B is this track, that would be perfect. But how?
I mean,
would
ultimately,
we
you could plot that down the road. You could plot that in a overlay of the camera and actually, you know, show a plane's track.
So, NG, this is right that it's for you, from your perspective, essentially a mathematics problem that you don't know yet how to solve it, or is there any?
exactly.
Okay. So maybe some people could support that and do the the coordinate transformations from GPS, and then you have the math. Yeah. Okay.
I think we should create an algorithm that from ADS-B and the local station geocoordinate and elevation, then derive azimut
And
and
orientation.
inclination, only the two values, and then you can compare the position of the object and the position of the station, resulting in two vectors and two degrees, sorry, two angles. That should give you a lot of enough match. Because in the view of the camera, I can help you in this. This is old photogrammetry stuff from school. But basically, what you then do is just take the center of the view of the image. Not of the 64 image, but of the full frame fisheye view, and the center is your zenith, so the vertical point on top of you. And I hope if the station is mounted correctly, so it is horizontally, then it's also the real zenith, not only the zenith from the fisheye. And then you just can derive. We know the opening of the fisheye. And then you can
degrees field of view, right?
You know how many pixels? Yes. And then you know how many pixels horizontally, vertically are there for representing this amount of degrees, and then you just interpolate.
And Richard, you could get you could adjust for any, you could correct for any offset by by the view of the stars.
Oh yeah, you can backward triangulate. Yeah. But I know the position of the station anyways, so.
Yeah, because we plan to have accelerometer or something, or gyroscope actually, on the station, or to align by hand. What we do.
So I cannot so these videos are made a couple of years ago. So. The last 4.
But in the future, if we're going to get data in the future,
yes,
just having another way to kind of ensure that.
Now I get what you mean. So by watching stars and retriangulating and seeing how the
where
object
the
is
focal point
placed
is.
in the exactly, okay. Yeah, that's absolutely in the plans.
So we can use ADS-B data to adjust coordinates, right, on a camera.
You could use the stars to know to confirm that the camera is
How it's oriented.
actually set correctly, or even that it's actually in line with what the accelerometer is telling you.
So you just need
as well.
stars and time.
I'm sorry.
Once again.
Say that
So
again.
For this method, you need a map of the stars and current time.
Yeah,
Yes.
and really, you're probably going to be close enough for this. For this, you're probably just going to need your geo coordinates, your lat and long, and the time and the precise time. That's really all you need, because you can look up historically. You probably don't even need the API. You can just look. You can look up through a number of apps, just those coordinates, and get the timestamps of the different flights that have crossed that within the view of that circular area, and then pull that video footage, and then you have your training data.
So basically,
and set that up next to an airport.
Okay.
And
so
that's
say,
no good.
Yeah.
Planes are too big in that case. We need also examples.
Just far enough.
So there are basically two steps. First is to get the correct orientation of the optic. And yes, we can do this via a set of, we do not need an API, it doesn't have to be online for that purpose. We can get the ephemerides of millions of stars. We pull out, I don't know, 20, so that we get a good bunch of that are seen anywhere on the planet. The nearest ones, the biggest ones, I mean, astronomers shall tell us. We take these ephemerides and then we look for them, because we have a basic setup of the station, basic orientation, so know where it is and what elevation it is and so forth. And then we try to find the stars and then re-triangulate from the stars where the station actually really is. And then we know where the zenith of the optic is, and we know where the real zenith is above, so there can be a deviation in it. And then you can make a correlation within the API of ADS-B, where you get the geolocations of where it's X, Y, and Z.
Nearby,
Of anything that's nearby, exactly, within the radius. I mean, there are APIs that give you the option for defining the radius close by, so you can filter out. And then you recalculate just the two angles, and then project them with a little bit offset via the off angle of the zenith, and then you should find it.
Yeah,
and you don't even need to adjust to the offsite. You don't need to do the adjustment to capture the training data. You would need to do the offset or the adjustment and the rotation to be able to do an overlay or to actually know the specific path that it's going to show up. But all you need to know is it's going to go in this this circular area, as long as you have a circular entire circular view, if that makes sense.
Yeah. So the final goal is to take unclassified data, that is all the tracks that are produced by Simple Tracker, and then to collect ADS-B data for aircrafts in vicinity, and to try to identify some of the tracks using this method, which uses ADS-B data, and compares to projects to these fisheye coordinates, and then we identify some of the tracks, and then we use these crops for machine learning training for at first just for aircrafts and maybe drones. Then we can use it to separate aircraft by type, because ADS-B also provides that. Is that the idea?
Oh yeah. You can only correlate with ADS-B with planes, of course. You can say it's a plane or it's not a plane. Yeah.
Yeah, at first, yeah. Yeah, seems like
And you can do the same thing. I mean, if it's at night, you can also do the same thing with satellites.
Yes, true.
Oh yeah,
Oh
yeah,
yeah.
yeah.
Absolutely.
Which is going to be a very good. I mean, that's probably the planes and satellites are the two moving lit things at night that
Keep the tracker
and
busy.
meteors are the the things you want to
Subtract.
maybe we
what is
should
that?
think about creating a system for storing the historic data related to ADS-B satellites and everything, because
it's all there. I mean, it's all
but is
there
it,
already.
is it
You
log or
can
is it just
go back historically.
Oh yeah, that is
Non-related question.
I-
I have a quick non-related question for Jacques, Dan, and John. Is our meeting next Wednesday at 12 p.m. UTC or 12:15?
12. I proposed 12:15 CST. I think that would have been 5:15 UTC. It would have been same times as Sunday. This meeting on Wednesday.
Okay, 12 o'clock or 12:15, same time. This time on Wednesday.
12:15.
Okay.
12:15.
Okay, sure.
I actually got to run,
That's
guys,
all.
but I just want to show you all something real quick before I go.
Okay, go ahead.
Super fast. Okay. How do you share a screen on this?
Hey, by the way, John, you wanted to say something before.
Yeah.
You were interrupted.
So I didn't completely follow the whole having an inventory of stars, but I wanted to add something. I'm posting it in this general chat, in the chat of the VC. So there's essentially the Yale Bright Star catalog. It's a data set of stars visible with the eye, and from that you could select the top, like for example, the top 20, 50, 90, whatever, brightest ones out of the data set, and then that would be a good starting point.
Exactly.
Nice.
Perfect. Thank you.
And John, what I just to clarify, it was to confirm that you know where the camera is focused.
Right.
You know, the focal point. You can know where the stars are going to be at a exact time.
Yeah, right. It's
with
like a
the
star sensor.
expected kind of, let's say, normal vector of the Earth at
It's a star sensor.
Geo-coordinate.
A star
it's like a
catalog.
star tracker.
The stars are not in the same exact place that you expect. It means that you're off somewhere.
Yeah, correct. It's a star tracker,
and
like
you
we use
can
on
know the
satellites.
rotation of the whole camera based on that. You know, based on where the stars, show up in your image. So
Gotcha.
it's just a way to correct for where the camera actually has been set up, and it would probably just confirm the accelerometer data as well. So it's just a secondary mechanism to make an adjustment.
Yeah, so these algorithms for calculating ephemerides are ages old. They exist, just have to be implemented.
But just give me if someone
or show something.
Keyword for me to follow.
Yes, Nicola. I will give you some links for photogrammetry and calculations, backward triangulations.
Okay, I'm just going to do this super quick. So this is just based off of what we were talking about earlier. I just kind of did it real fast. I found out that there's a way to just download the transcripts not really programmatically. Maybe I could write a scraper that could do it programmatically, but over here, this website was just super fast. Download YouTube subtitles. There's a way to do it manually.
I used it
and
to translate Brazilian UAP hearing. It's real nice.
Oh, nice. There's also this. There's a Python library that does it, but whatever. I was just trying to do it super fast, so I just used this. I downloaded the last the transcripts for the last meeting, the one that was on. Well, I did a couple, but I just did all of March. And then where's my tab? Hold on, I got a lot of tabs, guys. And then I just use this Lambda Hub, the data collectors, so that you can train ChatGPT on your own data, right? So I just grabbed that text file and threw it in here, and then boom, I just said, I'm not going to scroll up because I know this is being recorded. I don't want to show my secret key for ChatGPT, but here it is. And then I just asked, what was the summarization? Can you summarize this meeting? And let me zoom in. That seems pretty on point. So just a proof of concept that works.
Jeez,
I can just do that for the rest of the 49 meetings. And then I asked, what were the highlights for the meeting? And this is what we could just come up with a couple prompts, and then I can just rinse and repeat, make a Python script, just do this whole thing.
Okay.
It's like 30 minutes of work, right? So.
And Jack, I'm sorry.
That was you. That was all you. I just stole it.
No, good. That's awesome. That's it. My audio cut out for most of what you were saying. I think you were just kind of demoing doing this, so that's awesome. Did I miss anything critical at the beginning of this? But it seems like it's pretty straightforward and obvious and awesome.
Wow.
So I'll just do this for all of the demo, the dev meetings, and then just whatever, put it into, I don't know, a Google Doc or something, and just whatever we want to do with it, we could do with it. We could either put them into the videos themselves as like, here's a synopsis, or we could do whatever. We could use it as documentation. We could try to parse things out. It's not that much work. I was just like, what can I do right now to help?
Okay. Could we even add more points, like, for example, give me the five the most important topics that were discussed, so that we get let's say an overview, let's say hashtags, hashline, or whatever.
100%. How about we make a channel, like we were saying?
We can give our goals for the week, and he derives what is completed and what not.
You got it.
There you go. Let's make a channel and put all of that in there, because I have to run it, and my wife is going to kill me. I got to help with the kid. So it's
great job.
9 o'clock over here. I got to put her to sleep.
Great job, guys.
So
great job.
Talk to you guys soon. Bye.
Bye. That is awesome. Seeing your idea so implemented in the second. Wow.
Amazing. These tools can do things. Another thing that I've just with like research papers, a neat thing that I've tried that has been very effective has been to feed it the text and ask, what concepts do I need to know, to understand or learn, in order to kind of really be able to understand all the concepts within this, paper. So we could potentially do a very similar thing with meeting notes. So, like, what concepts would you need to really get up to speed on to understand?
Could we do this with documentation as well?
Yes.
Great onboarding AI.
Yeah. So, well, you could go. This is where I think this could be tremendously. Exactly. But I think this could be tremendously powerful if we look at parse the notes, break it down into those. There's topics that really are very important topics that have been highlighted, and then very, very easily kind of break them down into what you need to, how you get up to speed on that topic. And not only just getting up to speed on that topic, but you can project and say, okay, what other ideas are possible in this space? What haven't we talked about? What did we miss? What other ideas? So we can take this linear progression of ideas, and we can kind of backfill the ideas, but we can also go from any one of those tracks forward and say, okay, give us a few more ideas in that space, and validate that we haven't missed, or just fill in those opportunities. I think that's really
we will be managed by AI. Right?
Supplement, right?
Supplementally, that's the word.
Supplemented.
Supplemented.
Enriched.
John, you want to say something?
I just noticed that I wasn't muted. Then I'm muted. Sorry.
Okay.
I mean, I also want to say something, but it's not on this topic, so I will wait.
Okay. So anyways, guys, it's 4 minutes to the clock. Any other topic you want to raise or put on record? Rebecca, can you hear me? Nope. Okay. So otherwise, John, you want this to be on record? Okay, go ahead.
I think that it's no problem in being on record. So I have an additional suggestion on the on the side of the star detection for measuring the orientation, right? And we already, I heard something here in the chat earlier that we already have an sun. Essentially, we know already where the sun stands, and if you know the coordinates of a station, and you know at a given point in the time of the day where the sun stands, you can already use that for orientation. So that's maybe then says
basically yes. The only thing with the sun is, and the same is with the moon, that it creates mostly a huge blur, and it's hard to define the exact center. So with stars, it's more discrete. It's more easier.
Right.
Mostly in
and stars are everywhere.
Yeah. But yes, your station is then dependent on a clear night.
Oh yeah.
So when you're in a cloudy area,
I also imagine that station will need to. We need to think also about startup wizard, where you configure your station name, first name, last name, whatnot, and then you initialize the calibration period. I mean, final station will have Kraken SDR. It needs to adjust to the environment, to the direction where the default noise is in this location. And I imagine also the same for PTZ and even all SkyCam.
Yes.
There will be some calibration period.
True. We have to get. That was a long discussion from the very beginning, and my point was always that we have several cameras on the station, but they're all not oriented perfectly because people produce the stations themselves. It's not one company doing this and having a Q&A. We have to live with this inaccuracy in the builds and always compensate for.
So that pretty much
and probably continually
software, a lot of it.
Excuse me once again. Nicola, what did you say?
So this leaves us to correct as much things as we can in software.
Yes.
So do we have? Idea. My idea is to have some reference point on a station, so you can turn north or You know what I'm saying? So
Yeah,
each
we
station.
will use stars, most likely. Stars, sun.
Yeah, but some point, like a mark on a station. So each station will be points on the same way.
No.
You know
Like
what
if you
I'm
want
saying?
to take this measuring ruler with the bubble for how it's called, level stuff, for leveling. So you can align it
Yeah,
with this
in
line
origin.
closure.
No. Leveling is one thing. I'm talking about the position of the station. Each station, no matter where they are, will be on the same position.
No.
But that
Same
Like
direction.
oriented
would
to the
rely
north or
on.
something.
But people make errors. People
Yeah.
So
Yeah.
Because
you
if we
probably
trust clients to align the station, then we must trust in data produced by clients.
Okay.
but if you have one point, you probably actually, ideally, you have 4 points that there's no that are almost 4 nodes that are that don't move with respect to each other, so that you can get that specific reference node that's origin, but also have orientation. And I guess you would, orientation in 3D space.
So basically, it does not matter how the station is set up and how the camera is set up, because by our software we can recalculate the orientation of the cameras, each camera for itself. And when we have these intrinsic parameters of each camera, then we know all projections and we can triangulate and what have you. And this is something that the software has to do. But it is just, this is algorithms that exist since decades. It's all long chewed.
Well established stuff.
Well established, absolutely. But
are you saying if you're going to have if you're going to say, there is a position of the station, what is the precise position? What position of the station?
Actually,
exact position of the station are you referring to? You're saying there is a point on the station that you're referring to, a one, isolated point.
No, maybe I am wrong. For example, camera, all sky camera. You can turn, right?
Yes.
Freely.
Yeah, of course.
So let's say we can do, station can be whatever position. But the camera can be turned. And
but Bojan, this is only for human perception. You want north to be up, but mathematically it doesn't matter at all how it is oriented.
Okay, I just asking. I'm just.
No, it's just for your
maybe
perception.
But just.
I mean, we can do this. Rebecca's not here anymore, but we can do this in the user interface to have a nice view that's oriented north upwards. But mathematically speaking, doesn't make any sense. And basically, the end user will never be able to do that correctly, because it would need you a lot of hardware and knowledge how to use theodolites and photogrammetry and what have you, and astronomy probably. The layperson is not able to do it. So let them set it up, whatever comes out, we'll take it. And it's
okay, I just asked you, just
no. We had this discussion with Christian also. Christian is our astronomer, and he's used to do this, but as an astronomer, and he thinks that all people are astronomers and also be able to do it. And I said, no, it's not that way. So we can be happy if we create a system that is so easy to set up that everyone can, with the documentation, build it like an IKEA type shelf.
Plug and play.
Plug and play.
Astronomers is pointing on a north, always in the same direction telescope. Astronomers. This is my question coming from.
Not necessarily. It depends what your software is using for your mount head. If you have a software that uses your initialization process, that you point to a certain star or to north, Sirius or whatever, yes. But it's not, technically speaking, it's not necessary. You can have any kind of setup.
Yeah.
You can set a telescope on a slope even, and it could work. Just needs your software that compensates.
Remark from my personal experience has been that trying to get an exact mechanical alignment, like, you know, for true north or whatever, really is a pain in the derriere. And I mean, I've gone to some significant trouble trying to get it, and it's still a few degrees off. So to have the cameras so that, you know, we can mathematically correct the direction, I see that as a necessity. And of course, it's already, you know, obviously that discussion was handled long before I ever showed up. But yeah, just especially as you get to builders with less experience, the availability to do it, even when you're trying, is bad. So, you know, that's where yeah, have the display come up, north up. I'm a big believer in referencing things to true north, because the magnetic north has this nasty tendency to wander around a bit and so on. But getting your physical hardware lined up so that's looking straight due north is actually a real pain in the derriere. And
I know that
the more casual builders are not even going to think about it.
You will not
So
be able.
just a remark from my personal experience on the thing.
So in urban areas, it's not even possible. So you don't have just a big flat open area you can put things to. So some people only have a little console or a place on the roof somewhere, and you have to live with what you have.
We're going to have a Sky 360 for dummies, or it's never going to go as big as the other one. Right? It's going to have
to do it in software.
Yep. If I can figure it out, we got her made. I'm just dummy.
Guys, on this note, I'd say we close the meeting, the official one. I stop recording now.